Okay, ladies and gentlemen. What I'd like you to do today, let's do some investigation first of all. Okay, I want you to draw each point P and then draw the angle in standard position. So a review from last day. Okay, and then from there, I'd like you to then find the ratios for the three what I call primary trig ratios, which is sine, cosine, and tangent. All right. So let me show you the first one, and then hopefully you can try the next ones on your own. Okay. Let's plot this point P3, 4. So I'm going to go 1, 2, 3 to the right, 1, 2, 3, 4 up. And I'm going to ask you to draw the angle, okay? And that's the angle in standard position like this. Here's the angle, okay? And remember last day I said, hey, there should be a reference triangle that corresponds to that angle. I'd like you to also draw in that reference triangle. So I'm thinking right here in green. Okay. Now, before you do the ratios, I'd like you to label the lengths of all three of the sides on this reference triangle. So how about the horizontal piece? How long is that? The horizontal piece?
Yeah.
Just 3, right? The horizontal one. How about the vertical one? 4. Now, what's the slanted one?
5.
That's 5. Good. And if you're not too sure how to get the 5 there, remember, use Pythagoras. 3 squared plus 4 squared equals to that slanted side. I'll call it S. So S equals to 5. Okay? From here, use your definitions of SOHCAHTOA. So sine equals to opposite over hypotenuse. In this case, opposite is what number?
Are we using that?
Yeah, using the angle. So what's the opposite here? Which number represents the opposite side? It's 4. Good. So 4 over 5. Cosine, once again, is adjacent over hypotenuse. So what would that be? 3 over 5. Thank you. And then last but not least, tangent. Opposite over adjacent. How about 4 over 3? Okay? Now, I want you to do the same thing with the other ones now. Okay? Now, for part B, let me get the picture ready for you. P is reflected in the y-axis. So instead of over here, it's now over here. Well, what's actually changed? It's the x value that changed. So your new coordinate is actually -3, 4. So once again, plot and then draw, please. Okay. Draw your terminal arm. Okay. Draw your angle in standard position, which is over here. Okay. But once again, I'm looking for that reference triangle to help us find the ratios. And the reference triangle is this one over here using the reference angle. Okay. And I'm going to ask you to please label the lengths of the sides again. Okay. What's the length of the side that is horizontal now this time? -3. Good. Notice it's -3 because now I'm in the negative part of the x-axis. The y value, or the vertical, is still going to be 4, and the hypotenuse is still going to be 5. That's always positive, okay? Now, even though your angle in standard positions over here, the corresponding reference triangle is what I want you to use to calculate these ratios, okay? That's why I showed you how to find those reference triangles last day. So what's sine theta in this case? Well, sine, once again, is opposite over hypotenuse. What numbers are we talking about here? How about 4 and also 5? Okay. Cosine, how about -3 and 5? And tangent, what would that be? How about 4 over -3? Okay. Now, I'm going to let you try the next two on your own, okay? P is reflected in y, then in x. So you start over here, then you come over there, then you come down there. Okay, if you're curious what that coordinate is, it's -3, -4. And then the last one for D, if you just reflect it in the x-axis, you're down there. That means your coordinate is just the y values changed. Okay? I'd like you to try these right now, please. Okay? So -3, -4, it's way down here. Okay? There's angle theta. Your reference triangle is this. You're going to use -3, -4. Now, someone asked me, is the slanted part here -5? No, I want you to understand that the slanted part is always a positive number, so just keep it as +5, okay? And so your ratios here for sine, I believe they should be -4/5. Cosine is -3/5. And tangent is -4/-3, which simplifies to just +4/3, okay? And the last one, if you're not too sure about that one, let me show you the answer now. It's 3 to the right, 4 down. So here's your angle, way around. Okay. Your personal reference triangle is this. I put in purple. +3 for x. -4 for y, because you're now below the y-axis. And once again, regular 5 for that. So if you've got these ratios, give yourself a pat on the back. Yourself, not your friends. Okay? Any questions so far about this stuff? Okay, so here's what I'd like you to do now, because I'm going to actually show you a new way of describing these sine, cosine, tangent ratios. Okay? No longer will you use opposite, hypotenuse, all that kind of stuff. When you are given these angles in standard position, there's a new way of describing these trig ratios. Okay? So I'd like you to just once again draw a regular angle in, let's say, the first quadrant. Okay? Here's theta. And I'm going to ask you to put a point, we'll call it P, and the coordinates of P are x and y. So I'm going to write down P and the coordinates next to it, x comma y. Okay? Remember what I did in the previous questions? I drew in the reference triangle, so I'm going to ask you to do that as well, once again. Okay. And how would I label the lengths of these sides? How about the vertical side here? What would I call that if I give you, which one? Y. Good, it's the y value. Awesome. How about the horizontal piece? That'll be x. And now I'm going to use another variable to describe that slanted piece. I'm going to use the letter r, because if you think about it, it's kind of like the radius of a circle that I can draw out. Okay, so I'm going to use r for the radius of a circle. Okay? Now, by the way, what's the relationship between x, y, and r over here in the box? That's right, it's Pythagoras. So just to let you know, okay, by Pythagoras, the relationship between x, y, and r is this. X squared plus y squared equals to r squared. That's how all these things are related together. Good. Okay? Now, here's your new ways of describing sine, cos, and tangent. Okay? Here's my angle theta. What's the opposite side here? What letter represents the opposite side? Y. Good. What letter represents the hypotenuse? Good. So it's y over r. This is your new definition for sine when you're talking about angles in standard position. Sine equals to y over r. How about cosine? Where's the adjacent side? What letter? X. Good. So it's x over r. And last but not least, tangent, opposite over adjacent. That'll be y over x. Okay? I want you to know this stuff, okay? These ones as your new definitions for sine, cosine, and tangent, okay? Y over r for sine, x over r for cos, and y over x for tan. Okay? Now, let's move on. Let's continue on, okay? Now, for those of you who had me last year, I showed you this earlier, but let me ask you this. Look at your data up here and tell me which quadrants have a ratio for sine being positive. So look at the sine, the row of sines. Which ones are positive? Your angles in which two quadrants? I heard it. Which two? Which two quadrants give you a sine ratio that's positive? 1 and 2. Good, because they're both 4/5. So I want you to write down here quadrant 1 and quadrant 2. How about being negative? Which quadrants are those again? Of course, they'd be the remainder, 3 and 4. Okay. Figure out the rest here, please. Cosine and tangent. Try that on your own. Look at the actual chart from above and say, which quadrants now do I have cosine being positive?
1 and 4.
1 and 4. Okay. And then, of course, if 1 and 4 is positive, then 2 and 3 must be negative. Okay. And last but not least, how about tangent? So look back at your chart. Yeah, it looks like 1 and 3. So 1 and 3. Okay. And I'll show you why you need this in a second. Okay. We can summarize now what I just told you to write down here. What I like to do is in this little picture, I'm going to answer the question, which trig ratio, and please write this down, okay, is positive in each quadrant. Okay, that's the question I'm going to answer. Okay? And then I'm going to also review with you the relationship between theta and theta r in each of the quadrants. Okay? Help me out. Look at the first quadrant, okay? In the first quadrant, let's look back at your chart from above. Look at all the ratios. Are they all positive? You bet. So I'm going to use this. I'm going to call this all. All of them are positive in quadrant number 1. How about in quadrant number 2? So let's look back up top. Here's your numbers in quadrant 2. Which one is positive? The sign is positive. Good. So let me ask you to write down the name sine. Okay. Okay, go back now to the chart up top. Look at the third quadrant. Which ones are positive here in the third quadrant? Cosine. Oh, tangent. Yes, tangent. Good. Tangent. And then in the fourth quadrant, you can probably guess, it's cosine. Okay. So I want you to memorize this somehow, and this is what I like you guys to do. If you can just memorize the first letter of all these, right? A, S, T, C. I'll say all, and then S stands for, I don't know, I'll say students. And my favorite one is take. Yeah. Now, if you don't like calculus, you can go cooking. I don't know. You hate cooking?
Catering.
Catering. That's kind of like cooking. Chinese? Chemistry? Choir. Okay, whatever other C words you can think of, okay? But anyways, ASTC, all students take calculus. That's going to help you memorize which ratios are positive in which quadrant. Okay? C physics, okay. CPE, C science, C English, I don't know.
C science.
Annoying students take calculus.
Okay,
Asian students take Chinese.
all right. Now, let's go back and double check this relationship between theta and theta r. Okay, if you have your notes from last day, you can pull them out. But in quadrant 1, what do we notice about theta and theta r? They are the same. Good. So I want you to remember in quadrant 1 that the reference angle is the same thing as the theta angle. Okay. Now what about in the second quadrant? And if you're not too sure, I'll go back to my notes from last day if they come up. I believe it was 180 minus theta. You bet. So remember last day here, yeah, 180 minus theta, right? So 180 minus theta is equal to theta r. Okay. And then tangent, or the third quadrant, I think it was theta minus 180, which gave us theta r. And then the last quadrant, I think it was 360 degrees minus theta, which gave us theta r. Okay, now all this stuff will come in handy, I think, when we do questions on page 3, but I'm going to ask you to try to know this. It's even better if you can memorize this so that it'll be pretty accurate and quick for you to recall. Okay?
Wait. Can you zoom in on it?
Zoom in. Too small. Is that better? How about you get some glasses? Okay, so here's example 1. I'll show you the first one, you try the rest, okay? I'm saying here, I've given you a new point, point A, and it lies on the terminal arm. So I want you to draw out this point, okay? So for part A here, I think we're going to go 5 to the left, and then 12 up. Well, I didn't give you much space, so let's pretend this is 12. No shame. Imagine. Okay? Now, the standard position angle, of course, is this angle here, which I'm going to call theta. But I want you to actually create the triangle that is related to this reference angle. And of course, that would be this. Okay, and I'm going to ask you to please label the sides of this reference triangle. Okay. So let me do this with you. What's that vertical side, the up and down one? What's the length of that? Yes, the y value, so it's 12. How about the horizontal one? -5, good. And to figure out the slanted part, s, we're going to use Pythagoras, so -5 all squared plus 12 all squared. And I'm so nice to you in this case because I think this is a nice number. Yeah, it's a 12, 5, 13 triangle, right? Okay. Now, once you have all the lengths, you should be able to then go ahead and write out the three ratios for me. Okay, sine theta, cosine theta, and tangent theta. Write out the ratio. So I want the actual ratio, the fraction. Okay, now your new definitions for sine, once again, if you've forgotten, sine is now y over r, cosine is now x over r, and tangent is now y over x. Okay, so I'm going to ask you to try those, please, for number 2. I've started working on part C now, okay, and I noticed some of you said, well, Mr. Lee, should you give me a decimal? I don't want a decimal, actually. In this case, I know that this is a nasty number, but for our purposes, if you can just write down root 149, that'd be perfectly fine for me, okay, for S. And the reason why I'm saying this to you is this could be a question I give you on the non-calculator portion of the test. Okay, in this chapter, I will be doing non-calculator and calculator stuff. So this is a question that will be on the non-calculator portion. You should be able to do this without the calculator.
What if we don't
Okay?
know that the square root is 3?
You don't need to write down square root of 149. You just need to write down root 149. And I wouldn't give you ugly numbers, right? I'm thinking you should know how to do the square root of -10. And you should know the square root of 7, so that's not that hard, right?
No, I mean like for like B, if you're like the square root
Well,
of
for
3,
B,
nine.
maybe this one is too big. I wouldn't give you these numbers, okay? All right, no. Now, to let you know how to do part C then, so once you get all three of your sides, once again, you should be able to write out the ratios, okay? So, sine theta is equal to, in this case, y over r, which is -10 over root 149. And you don't need to rationalize the denominator, whatnot, just leave the square root in the denominator, that's perfectly fine, okay? Cosine theta for this one would be the adjacent side, which is 7, or not the adjacent, the x, I guess I'll say, x over r. And the last thing I have for you is tangent theta, and that would be equal to y, which is -10 over x, which is 7. Okay? Theta, yeah, but I'm saying now the definition is using the y and x and r. And when I asked you for the theta, we're looking at the actual triangle created by theta r. Okay? Now, ladies and gentlemen, I apologize for this next part. I actually had this little thing that I could actually show you with. I think what I'll try to do is I'll go home tonight, and then my internet I know works at home. I will then try to show that on the computer. I'll record it and I'll put it online so you can see it. Sorry? I'll put it on YouTube then, sure. But I don't know why it doesn't work right now. Okay?
Your voice described would be like
Sorry?
YouTube video.
The graph yet, so I can't. Okay? Now let's do cosine of theta then. Cosine is defined as what? X over r. So in this example at 0 degrees, what is my x value? 1. And my r is also 1. So the answer here is 1. Okay? And then last but not least, I've got tangent, which is defined as y over x. So in this case, it'd be 0 over 1. So the answer is 0. Now, I can double check all these by using the calculator, right? Cosine of 0, just punch it in, you get the number 1. Tangent of 0, you punch it in, you get the answer of 0. But I'm trying to show you why this is the case. Okay? Now, let's take a look at part B, because I guess we want to look at part B. And let's draw a picture for part B, please. So in part B, your angle is now at 90 degrees. So we're going to start on the terminal arm. And here is your angle up here. Here is theta. Now, where's your triangle? Well, your triangle is just right here on the y-axis. Confused, but weird. Let me ask you in this case, can you identify the x value, the y value, and the r value? Okay, so here's my point right up there. First of all, what's r? I said r is always 1. Now, if the point is up here on the second or on the y-axis here, between the first and second quadrant, what's my x value? Right, there's nothing for x, it's 0. What about y? 1, good. How come x is 0? Because my coordinate now is up here. So what's the coordinate of this point? The x value is 0. You didn't move anywhere. It's just the y value that moves. You moved up. And I'll say you moved up 1 unit. And once again, I wish I had that applet to show you. I will put that online tonight when I get home. Okay? All right. Go ahead and figure out the actual numbers now for sine 90. Somebody help me out. What's sine 90? 1 over 1. Good. Which is just 1. Don't believe me once again? Go to your calculator. Sine 90. The answer is 1. Okay? Figure out cosine, please. Which would be x over r. And x in this case is 0. So 0 divided by 1 is just 0. And then what else do we have? Tangent. And I believe that's y over x. So that'll be 1 divided by 0. Now what's 1 divided by 0? It's undefined. There's no answer. Okay, so can I, no limits right now. Just use the idea and write down the word undefined. On your calculator, if you did that, if you typed in tan 90, it will tell you it's domain error. ERR is error, meaning I don't know what it is. Okay? Or undefined. Okay, so remember when you divide by 0, you have something that is undefined. Okay? All right, let's try C. I'll draw the pictures for you, and then for D, hopefully you can try that on your own. Okay? Okay, the picture for C, which is 180 degrees. Here we go. So initial arm, and I'm going to create my terminal angle, and you're actually going to lie over here on the negative x-axis. There's theta for part C. Okay? Which means your triangle is really just flat on the on the x-axis over there. Okay, just right there. And once again, I will help you out by telling you what x, y, and r are going to be. Once again, what is r? I'm always assuming in this case it's equal to 1. What's my y value in this case? 0, right? It's lying flat on the x-axis. There's no y. And how about the x value then? Not 2. It's still going to be 1, but which side of the x-axis am I on? Yes, the negative side, so let's make it negative 1. Okay? So go ahead now and use these and find the ratios. You can always double check with your calculator. Okay? And then I will quietly draw D, and you can try this on your own, and then let's see if you can fill out the rest of the table. Okay? The rest of the ratios for this chart. Now, I'm going to suggest that you memorize these. Okay, but if you can't, then hopefully you'll find a way to create this chart. Okay, remember last day I gave you that chart with the special angles? 30, 60, 90? Or not, sorry, 30, 45, 60? Yeah. You know what? I can actually extend that chart to include some of these nows. Okay, so if you are interested, may I suggest you do the following with some extra space over here. Okay?
If you're interested.
Meaning you should be interested. But remember this chart from last day as a quick review? Remember that? And I said sine, cosine, and tangent. And I gave you a nice little pattern. Remember that? Well, I'm going to now extend this chart, okay, to also include the following. Not just the 30, 45, and 60, but now, since I've given you these quadrantal angles, I want to include 0 and also 90. You should be oohing and awing, because this is going to be like, ooh, oh, very good. Not bad. We'll listen to the recording afterwards. We'll see how it goes. Okay. Now, remember what those original things in here were? Remember the pattern? What was the pattern?
Oh, root 1, root 2, root 3.
Root 1, that's right. Root 2, and root 3, all over 2. And then with cosine, what happened? Right, we switched the order. Start with root 3, then go root 2, then go like that.
4
Okay.
over 2 equals 1.
Now, how do we do tangent again? We took, 1 over root 3, so 1 over root 3, right? We took this divided by that. And then for tangent, I believe it was just root 2 over root 2, which is 1. And then that's just root 3 over 1. So tangent, of course, was, once again, sine over cosine. That's just a review from last day. Okay? Give you a chance to write that down. Now, I want you to fill out the chart for 0 and 90, which I had over here. And let's see if you can continue this pattern. Okay? Yeah, this is all from last time right now. These 9 are from last time. Okay? Sorry if you don't have a space. Okay? Now, here's the new stuff. Okay? New stuff right here. Let's take a look. What's sine of 0? Look at your chart.
0.
0. Good. Wait a minute. That doesn't look like the other ones. Let me make it divisible by 2 as well. What's 0 divided by 2? Well, that's still 0, right? Okay, but I don't have a root. Can I make it a root?
Yeah.
Oh yeah, root 0 is also the same thing as 0. Oh. Okay, now, let's go over here to 90 degrees. What's sine of 90 degrees by your chart over here? It's 1, right? Now, let's see if we can write the number 1 as a fraction with a denominator of 2. What will the number be on top? 2, right. 2 over 2 is the same thing as 1. Agree? Now, how can I rewrite the 2 as a square root? Nice. Root 4 over 2. Do you see the pattern now? Root 0, root 1, root 2, root 3, root 4, all over 2. Don't you like patterns? Okay. Now remember, cosine is just the opposite, right? So remember, cosine of 0 was 1. Well, 1 is the same thing as root 4 over 2. And then cosine of 90 was, what was that? 0. So that's just root 0 over 2. And then the same thing for tangent still works, because that's defined as sine over cosine. So take root 0, divide that by root 4. What's root 0 over root 4? Well, that's just 0. And then if you're looking for tangent of 90, it's root 4 over root 0. Remember, when you divide by 0, you get undefined. Okay? So I don't know if this extended table works for you, but I kind of like it. I like the pattern, root 0, 1, 2, 3, 4. Don't forget to divide that by 2. And then the other way, root 4 all the way to 0. Okay? Now, you're going to use this table for the questions on the next page, so keep that in mind. All right? But before we do that, I want to do one more question with you, where you have to draw things out and find the ratios. And then we'll go on to that more challenging stuff. Okay? So let's take a look at this last one, example number 2 on page 2. It says now, suppose theta is an angle in standard position with terminal arm in quadrant 4 and the sine ratio being equal to negative 2/5. Find the exact values of cos and tan. Okay. Draw me a picture, please. Okay. Draw me a picture, please. Now, which quadrant should this angle be in? Which quadrant is this be in? Which quadrant is this should be in?
Wait.
Quadrant 4. So I'd like you to do this, okay? Just draw some random angle in quadrant 4. Okay? That's theta. And then I'd like you to, like all the other questions, draw the reference triangle that relates to this angle theta. So I hope you can see that the reference triangle should be in quadrant 4 like this. Okay? Now, I actually gave you one of the ratios already. And that ratio should help you figure out the lengths of the sides of this reference triangle. How? It's opposite over hypotenuse, right? But now I don't want to use that. I want to use the letters. What's sine theta defined as? Y over r. Good. So I want you to compare now y over r with this negative 2 over 5. Can someone tell me what the y value is? Okay, is it 2 or negative 2? Who says 2? Who says negative 2? Right. It should be negative 2 because look, your y value is below and it's downward. So the y value here is negative 2. So note y is negative 2. Remember, what's r? R is always positive anyways. So in this case, what is r? R must be the number 5. Good. Now before you actually find the ratios of cos and tan, what else do you think you need to calculate here? X. So why don't we go ahead and find x first, and I hope you know how to do that. Good times with Pythagoras. Okay. Be careful which one you use for the c value. Okay. Leave it in root form, yeah. Leave it in root form. So x squared plus 4 equals to 25. X squared equals to 21. What's x then if x squared equals to 21? Let's not leave it. Let's give it to me as a root form. It's just nicer that way. Okay? Especially when I say exact values. Okay? So when you see the word exact values, leave it as a root. Okay? All right. Go ahead now and figure out what cosine theta is and figure out what tangent theta is. Okay. Try it on your own, please. Figure out cos theta. Figure out. Okay. So notice that cosine theta is defined as x over r. So I'm taking my x value and then dividing it by r, which is 5. Okay. Can I make one note here, please? You know when I took the square root here? Technically, there should be a plus or a minus, all right? But why did I choose to use the positive one for x, not the minus one? Because if you look at my diagram, x is on the positive side of the x-axis, so therefore we'll just keep it positive. Okay? All right, I'd like you to turn the page. Let's skip that special triangle stuff because we've done that already enough, so I'm just going to skip. And let's actually do one of these questions here, example number 3. And I'm only going to do one of them, and I think I'm going to stop, okay? No, just skip the top part. We're going to do example number 3. Okay? Now, ladies and gentlemen, once again, there is a non-calculator and a calculator portion of the test. This is going to be a question that you can see on the non-calculator portion. Now, I know I can just tell you to go tangent 135 on your calculator, and you get the answer. Tan 135. The answer is -1. Okay? But I want you to figure out a way to do this without the calculator. All right? I'm going to show you actually how to do this in 2 different ways. All right? Now, what I'd like you to do first of all with method number 1, and there should be enough space in the box to do that, is to first draw me a picture. Okay? Where is 135 degrees? What quadrant would that be in? Second quadrant? Okay. So let's draw that standard position angle in quadrant number 2. That's 135. Okay? So method number 1, draw picture. Now, what's our definition for tangent again, using our new letters? Tangent is the same thing as what? Y over x. Good. So what I'm going to ask you to do, once you've figured out this drawing, is to create your reference triangle. And I'm going to ask you to try to label the sides of the triangle and then use that knowledge and this definition of tangent equals to y over x to figure out the ratio. Now, this is what I mean. Draw the reference triangle for me first, okay? Now, This reference triangle should be very special to you. Get it? Special to you. What type of special triangle is this?
45.
Yes. This is a 45-degree triangle here. Okay? And let me tell you, they will always, okay, listen up. They will always be special triangles. Because if they're not special triangles, you cannot do this without the calculator. Okay? So this special triangle is the 45-degree one, so you should know the actual length of the sides. What are they? 1, root 2. Yes?
Yes.
Not really.
Not really. You made me write it.
The y value is correct.
It was
The
negative
hypotenuse is correct, but because you're in quadrant number 2, this should be -1. Yes, -1. Okay? So method number 1 is to, first of all, draw a picture. And then draw triangle, the reference triangle. Then label the sides. And then now find the ratio. That's the last step. So once you've labeled the sides, it's like the previous questions we had, right? Once you know all the sides, you can now figure out the ratio for tangent. So therefore, what is tangent 135 equal to? Well, remember tangent is defined as y over x. What's my y value here? Yeah, y value is 1. Right? It's y over x, so y is 1. What's x? -1. So what's tangent 135? What's 1 divided by -1? It's just -1. There's your answer without the calculator. Okay? Now once again, if you don't believe me, go to your calculator, punch out tan 135, it's equal to -1. Okay? Now, that's one way of doing it. Okay? I'll show you one more way, and then I'll stop for today. With 3 minutes left. I can do this in 3 minutes. That's good too. Method number 2. Here's what I'd like you to do. No space? Well, use some space from above then. Okay? Here's method number 2. Okay? I still want you to draw the picture, because I think that part's important. Okay? So, just use the one from before. Okay? But what I want you to do now is I want you to find, not actually draw the reference angle, but find the reference angle. Find, not triangle, oops. Find the reference angle. Okay? Now, what is the reference angle in this case? Right. In this case, the reference angle, theta r, is 45 degrees. Everybody see that? From the picture from above? Okay. So what I'm saying to you now is the following. They actually share the same triangle. So if you think about it, and I'm going to try to go here now. Let's hope this works. Okay, you see how I have a triangle that's 45 here? If I actually want it to be 135, you see this triangle here, 135, and the reference angle is still 45? See that? Should I go back in? Right? And then 135 is the angle, and you got 45. Now, my question to you now is this. What's tangent of 45? Okay, now this is where you go to that chart that I actually showed you. So think about it. I'm saying to you now the following. Tangent 135, and please write this down, is almost the same as tangent of 45. Okay? Except there's one extra thing that you need to think about. Which quadrant is the angle 135 located in? Second quadrant. This is where that ASTC stuff come in handy. Okay? Find reference angle, and I'm going to say use ASTC. Why do I need this? Tell me, in the second quadrant, is tangent a positive ratio or a negative ratio? Right? Sine is positive, everything else is negative. So therefore, I want you to make this equal to negative. So what I'm saying to you is tangent of 135 is the same thing as negative tangent of 45 degrees. And what is tangent of 45 from the chart
What chart?
or the table? That chart on the previous page, this chart over here, tangent 45 is which one? 1. Good. So from the chart, okay, and I'll say from the chart, this equals to 1, so your answer is -1. Ladies and gentlemen, before you go, let me modify your homework assignment.
Oh, again? So ignore this one?
Ignore the one on the bottom of the page. Home learning, here we go.
Can you like make it easier?
Page 96, it's easier.
Can you actually do like 5 buttons?
Page 96, yeah. And I like you to only do the following, okay? Questions 1 to 6, just do A and C, okay? Nothing else. Okay, question number 7, you should be able to do all parts. And then for number 8, you should be able to do A. Let's do C and also D. And we'll leave the rest for next day. Okay?
I'm actually doing
This stuff is actually not that bad. Next day stuff will be not so fun.
I like how you